Hello, good day viewers. Into this tutorial we are going to see the exact differential equation. So for any exact differential equation, an equation must satisfy m of x y dx plus n x of y dy, it is equals to 0. So for an equation to be exact, this is the same thing as what? The partial derivative of what? Y. The partial derivative of m with respect to y, it is equal to the partial derivative of what? Of n with respect to what? With respect to x. Suppose I am given a question which says that, show that, let's say the question says, show that x squared plus y squared dx plus 2xy dy. So I am asked to show that the equation is exact or not exact, and therefore I am asked to what? And find this, and let's say find the solution of it. So for the equation to be exact, I have to say that let's say the function of x and y, it is equals to x squared plus y squared dx plus 2xy dy. So I have to take a look to this. I have to let this to be m. I have to let this to be what? N. So therefore m, this is the same thing as saying the partial derivative of what? M with respect to y should now be equals to what? X squared plus what? Plus y, and the partial derivative with respect to partial derivative of n with respect to what? X, this should now be 2xy. So I have to differentiate this with respect to y. If I differentiate with respect to y, the x squared should what? Should keep as what? As constant, so therefore it will be 0. So the derivative of what? Of y squared, it is the same thing as 2y. So the partial derivative of m with respect to y should now be 2y, and therefore for the partial derivative with respect to n with respect to x, this should now be what? If I differentiate this 2xy with respect to what? X, the x will treat as, it will become 1 multiplied by y. 2 times 1, which is 2, multiplied by y, which is what? 2y. So therefore this should now become 2y. So as you can see, the equation is exact. 2y, it is equals to 2y. So therefore this equation, it is what? It is exact. So, and hence I am to find